All right, let's take a look at the equations at the top of the paper. These should look very, 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 very familiar. If you recall, these were used in our blood splatter unit. So we are going to use this. This is if we're trying to find the angle of impact. And if you remember correctly, you're going to use the inverse sine of the ratio to find the angle of impact. For the tangent angle of impact, please notice that we're using more specific vocabulary, and we're talking about the height of the shooter versus the distance from the shooter. That's going to be very, very important as we complete these. So, first thing that you're expected to do is to draw the crime scene with measurements and then show all your work. I found that most students who were completing this work, the ones who struggled the most with understanding what was happening, did not draw the picture. So please, please, please read through and draw the picture. So let's start with our picture. A 6-foot man was shot walking his dog. Okay. So I've got a 6-foot man who has a dog. Got it. Asked me to put my measurements. Got it. 6-foot man. The bullet wound had a major arc of 12 millimeters and a minor arc of 11 millimeters. There was one witness at the scene who said they saw... Ooh. Excuse me, I'm sorry. There was one witness at the scene who stated that they saw a flash from one of the apartment buildings approximately 20 feet away. So we have an apartment building. My sketchy windows. So the first thing I want you to draw is going to be the path of the bullet. Now I don't know where on the building the shooter is. I also don't know where on this person's body that they were shot. I'm going to start by saying I think it's a torso shot and just hitting in the middle of the body for now. Or nope, I'm going to start at the feet. So let's say he's shot at his feet. Not sure where that bullet is coming from, but that is going to be my path of my bullet. Therefore, the height of the shooter is here. And then the distance from the shooter. Trying to see if there was a quick shape adder. It's not. Okay. So you can see this triangle we've formed. That's assuming that this location over here, what's happening over here, is going to shoot him in the foot. Well, what happens if the wound is actually in his abdomen, or in his chest, or in his head? This entire triangle is going to move straight up and down. So not the man. Undo. Just the triangle. So this triangle can move up, the triangle can move down, but that's going to impact where the person gets shot. Okay. Oh, last piece to label. Distance from the shooter is 20 feet. Okay, so first things first, I need to find my angle of impact. Remember, this is always going to be the inverse sign, and this should always be a decimal, so it should be the small number over the big number. You go to Desmos, function button, inverse sign, back to the main button, 11 divided by 12. So it's going to be a 66 degrees angle of impact. Now, we're going to use the tangent function. And we use this angle of impact. And then that's going to be the height of the shooter. Okay, height of the shooter. Not the height of the victim, the height of the shooter. So I could see that the height of the shooter is my unknown. And then my distance from the shooter is going to be 20. To solve this, we're going to do opposite operation. So the opposite of divide is to multiply. Therefore, the height of the shooter is equal to 20 times the tan of 66. So, 20 times the tan of 66. So the height of the shooter is 45 feet. But wait, we have to ask ourselves, does that answer make sense? So when we first started talking about this, we started about moving this triangle up and down. So this 45 feet is assuming that the shooter gets shot in the foot. Well, if the victim is shot in the leg, then we're going to move the entire triangle up. And so the height is no longer going to be 45 feet, but it's going to be 45 feet plus the distance from the ground to their leg. And if they are shot in the abdomen, it's going to be 45 feet plus the distance to the abdomen. So, what is the total height of the individual person? 6 feet. Therefore, 45 feet is not our correct answer or complete answer. We have to include the entire range. So 45 feet plus 6 feet, because it can be everywhere in between. So the height of the shooter is between 45 feet and 51 feet. And the reason why we cannot come down to a single answer is because we do not know where the victim was shot. All right, let's look at the next question. A woman who was sitting in her car was shot and pushed out of her car to the ground. All right, let's first draw a person sitting in their car. Okay. There's a person sitting in the car. So, from the bullet casings found, it was determined the shooter was on the second floor of the apartment building. The height of the person was 4.5 feet. And the second floor is about 23 feet off the ground. How far away? Sorry, the angle of impact was determined to be 25 degrees. So I'm not going to have to do this because it's already given me my angle. So we're trying to find how far away it was from the building. So again, I already have my path that the bullet took. Remember, we have to find the height and the distance. This is our triangle. Now, the problem I have with my height on my drawing is that I'm not going all the way down to the ground. So the previous image, the injury point was all the way on the ground, which is why I had to add my 6 feet to this, because I could go from the feet all the way up to the head. In this scenario, I know where both of them are. But the problem is my triangle is no longer on the ground, so I cannot use 23 feet. My triangle is up in the air. The bottom edge of my triangle is at the height here. So I must first subtract my 4.5 from the height of the building in order to find the actual height of my triangle, that the difference between where the person was shot and where the person is doing the shooting from. So let's write our formula. We've got tan of 25 degrees is equal to, remember, it's the height of the shooter, so we're looking at 18.5 over the distance. Now, one thing I like to remember is that when I just have the variable at the bottom, that means I can flip-flop these two. So our x is going to be equal to 18.5 over the tan of 25. I go to my calculator now. 18.5 divided by tan of 25. So the distance from the building to the victim is 40 feet. Now, if you were given both of the measures of our tangent triangle, and not given our major and minor arc, if this part is our unknown, you can simply do the inverse tan of your height over your distance. But this is only when they do not give you the minor arc and major arc. All right, flip over the paper, make an attempt. It's okay if it's wrong, and I will see you next class.